Yeah, welcome back, guys, to the next week of KDD2. I hope you all enjoyed the spare time after the week off and utilized the free time for catching up or something else. And now we try to close this lecture on high-dimensional data analysis this week. So we are left with correlation clustering. Maybe let's have a short recap. We are in the clustering high-dimensional data subsection, and we talked about challenges. And actually, we came up with a kind of classification of methods that try to overcome those challenges. So the most important challenges that we now try, or the solution to the challenges actually, is that we now try to integrate feature selection, feature reduction, feature learning into the clustering process, because finding the right subspace and finding the right cluster somehow depend on each other in a kind of vicious circle way. So we have to integrate that and simultaneously search for subspaces where the clusters live, and also for the clusters with the corresponding subspaces. Yeah, and we came up with a classification, as I said before, where one of the major classes, or one of the major class of algorithms deals with access parallel subspaces only, and those are the subspace clustering and the projected clustering approaches. The subspace clustering approaches, as you may recall, basically follow a bottom-up subspace search strategy, whereas the projected clustering algorithms do it the other way around. So start from the full-dimensional space, feature space, to find the projections, the subspace projections where the clusters are accommodated. And then we had a kind of different approach with pattern-based clustering approaches that look for patterns in the data matrix. Yeah, so they don't have, the other approaches have more a spatial view of the problem, and they have more a data-centric view of the or data matrix centric view of the problem. So they try to find specific patterns in the data matrix, meaning they try to find matrices that have a specific homogeneous pattern, like constant values, or those constant values in rows and columns and stuff like that. We saw that some of them are actually special cases of subspace clustering or projected clustering approaches in the spatial sense, where we have access parallel things, and some are somehow a little bit in the direction of correlation clustering, where, well, we talked about correlation clustering approaches before, just briefly, that they are capturing, or they are searching for arbitrary oriented subspaces, not access parallel subspaces anymore. And those pattern-based, some of the pattern-based approaches actually can capture a special case of arbitrary oriented subspace clusters, which we also call correlation clusters now. And now the last subsection of this section 5 in this lecture here is about correlation clustering, which is kind of the ultimative step in the evolution of all those approaches. So actually, historically, people start with proposing subspace clustering algorithms and projected clustering algorithms, then somehow also pattern-based clustering algorithms, and those correlation clustering algorithms that somehow generalize the whole thing are historically the one that have been proposed latest, so to say. Yeah? And why did people focus on the access parallel stuff before? Well, we talked about that because the search space is, for arbitrary oriented subspaces, the search space is at least potentially infinite. Of course, it's bounded somehow by the number of points, but you may have any arbitrary oriented subspace. If you focus on just access parallel subspaces, you have 2 to the power of d, where d is the number of features. So that was basically a performance issue that people first focus on those access parallel clusters. Anyway, so we will start with correlation clustering now.